Hello, let us see this question of relation. R is relation given by this. We want order pair xy, where condition is x plus 2y, we want 6, x we want whole number, and x we also want less than or equal to 10, and y we want from integer, belongs to z means we want y integer. So first say here x we want whole number and less than or equal to 6. So as x is from whole number such that x is less than or equal to 10, so which values of x we can write here? So we know that whole number starts with what? 0. So first number is 0, next whole number is 1, then 2, then 3, 4, 5, 6, 7, 8, 9 and 10. This is less than or equal to 10. So write 10 also. So from 0 to 10 write all whole number. So this is x. Now we want to find corresponding y. That means for x find out value of y. How we can find? Their relation is given. X plus 2y is 6. So now x plus 2y is equal to 6. So first select 0, or first here find out y from this x. That means we can write here 2y is equal to 6 minus x, right? And so y we can write 6 minus x upon 2. So write y in terms of x. So now first for x is equal to 0, what is y? Y is 6 minus x, that is 0 upon 2, that is 6 upon 2, 3. Okay, this is first value of y for x is equal to 0. Next, for x is equal to 1, y is 6 minus x, that is 1 upon 2. 6 minus 1 is what? 5 upon 2. 5 upon 2 we can write 2.5. Okay. Now here condition is y we want integer. Now this is 5 upon 2, that is 2.5. That is what? Rational number, that is not integer. So here we can write this does not belongs to z. Here this 3 belongs to right z. So order pair we can select 0, 3. Don't write this 1 and 2.5 because 2.5 is not integer. By this given relation we want y integer. Okay. So next, after 1 write 2. For x is equal to 2, y is 6 minus x, that is 2 upon 2. So this is 4 upon 2, that is 2, and 2 belongs to what? Integer. So where we can write 2 belongs to z. Next, for x is equal to 3, y is 6 minus 3 upon 2, that is 3 upon 2, which is not integer. Next, for x is equal to 4, y is 6 minus 4 upon 2. 6 minus 4 is what? 2 upon 2, 1, which belongs to integer. Next, for x is equal to 5, y is 6 minus 5 upon 2, that is 1 upon 2, which does not belongs to integer. Next, for x is equal to 6, y is 6 minus 6 upon 2, that is 0 upon 2, 0. 0 is an integer, right? Next, for x is equal to 7, y is 6 minus 7 upon 2 minus 1 by 2, which is not integer. Next, for x is equal to 8, y is 6 minus 8 upon 2 minus 2 upon 2 minus 1, which belongs to integer. Next, for x is equal to 9, y is 6 minus 9 upon 2, this is minus 3 upon 2, which does not belongs to integer because that is fractional. Next, for x is equal to 10, that is last number. Y is 6 minus 10 upon 2, that is minus 4 upon 2 minus 2, which belongs to integer. Okay, so now write R in terms of order pair which satisfy this given condition. First we want x whole number, and from 0 to 10, because less than or equal to 10 is given. Okay, but why we want integer such that x plus 2y is 6. So here select that order pairs where y belongs to what? Z. So we can select this first one. Okay, this is not belongs to Z, so cancel that. Next we can select this one, cancel this. Next select this, cancel this, select this, cancel this, select this, cancel this, and select this. Okay, so let us write R which satisfy given relation. So R first write 0 3, then 2 2, okay, 2 2, then 4 1, then 6 0, then 8 minus 1, and 10 minus 2. That means here when x is even, that time y is what? Integer, because 6 minus x upon 2 we want integer. So that is possible when x is even number, not odd number, right? So just we have write here directly. So these are the required order pairs. Okay, this is relation R. That is the first question. Now second part, we want domain and codomain. So first, what is domain and what is codomain? So if some relation is given from set A to set B, suppose just for example here 2 goes to 4, 3 goes to 9, 4 goes to 16, and here some 17 is given. This is set A and this is set B. This is given relation R. So by this relation R, 2 goes to 4, 3 goes to 9, 4 goes to 16. We can say f of x is x square. That is given relation. Now this set A is called domain. This set B is called codomain, not range. Okay, this is called codomain. So if relation is given or function is given from A to B, A is called domain and B is called codomain. Now what is range? Range is collection of these images. 4 is image of 2, 9 is image of 3, 16 is image of 4. So here what is range? Range is 4, 9 and 16. Okay, B is codomain. So 17 belongs to codomain, but 17 is not image of any number. So 17 is not in range. So we can say range is subset of codomain. Okay, so here range is 4, 9, 16. So order pairs we can write 2, 4, 3, 9, 4, 16 in this example. So here what is domain and what is codomain? So domain is what? This x always. This we write x and y as order pair. We can write 2, 4. So x is 2, that it belongs to domain, and this belongs to what? This codomain, or we can say range. So here what is domain? Domain is this 0, 2, 4, 6, 8, 10. What is codomain? Now what is codomain and what is range? Okay, so how we can find here codomain and range? This 3, 2, 1, 0, minus 1 and minus 2, this we can write range or codomain, as these are the collection of, we can say, images. This is called range, right? Collection of images. So this 3, 2, 1, this belongs to what? Range. Now what is codomain? So in given relation R, see y given as what? Integer. Y belongs to integer. So this second y, this is like x and this is y. So this we want from integer in this question. So here what is codomain? Codomain is integer given set Z. Now write range. So write images, that is 3, 2, 1, 0, minus 1 and minus 2. Collection of images. That is second part, y part. Okay, so 3, 2, 1, 0, -1, -2 right here, that is what our range. Okay, so this is our domain. Codomain is integer, set of integers, and this is range. Okay.